Primary School.
My name is Guo Cheng Guang, 8 apply to all of YUMIN Primary School.
This lesson is Calculus, Chapter 6, Definite Integral. Do you still remember for last lesson, we have this sphere and
Yes.
we proved that the surface
And
area,
this method is called the shell method.
we proved the surface area and the volume, right?
Yes.
But what you're talking about for the shell method, what is it? What is it like?
For example, an egg. So actually, for example, there's an egg. Then inside the eggshell, there's another eggshell, and so they keep on going down.
Okay, well, first we had that shell method, right? Which we had done it last time.
Yes.
Which method would you like this time?
Disc.
Sure you want the disk method?
Yeah.
For this disk method, we actually have 3 ways of using it.
Yep. X, Y, Z.
What are X, Y, and Z?
So
There are
it
3
means
X's, right? And remember, this is for those 3D, yes.
For example, the 2D, right?
Yeah.
3D will be more like this, right?
Oh, well, actually, if you want to draw the back, you use the lines, okay? So, for this, the x-axis, the y-axis, and the z-axis, they are the axis, right?
Yep.
So, what do you know about a disk? What is a disk?
A disc is something like a lot of circles.
A disk, for this type, a sphere. What shape is a disk?
Like, for example, like this.
A circle, right?
Yeah. Actually a circle. But it's as thin as possible.
Yes, which makes it like a circle.
Yep. 2D.
So for this, and remember right now, the disk, which is a whole thing, inside is solid, okay?
Okay.
And for this, what is the thickness?
The thickness is dz.
Yes, correct, it is dz. Then for this, what is this for?
This is the area of the circle.
That is the locus equation for the circle, right?
Yep.
And remember this, we actually relate it to analytic geometry,
Yes.
right? Remember this analytic geometry and calculus, they can
Combine.
come together, okay?
Yep.
Then how about this?
This is a sphere.
Circle sphere, right?
Yeah.
Okay. So for this, the x, y, and z first. X and y. Or just from this point, right?
Yeah.
Well, next, for, if we have a z, it will be like this.
Yes.
Okay, for example, at this point, remember this is in 3D. Okay, so it is not on this y-axis,
Yes.
right?
Okay, so actually it's something like this. Something like this.
a dot. Like in this case, x and y, first you can get a dot somewhere over here, right?
Yep.
After that, when you have the z, it'll go up. And this is x, right? The x-axis. This is the y-axis. And then this is the z-axis, okay? Okay?
Yes. X, Y,
X,
Z.
Y, Z.
Okay.
Okay, so for this,
So it actually be like this.
what would you want me to use first? Is it go according to the z-axis, x-axis, or the y-axis?
So it will be going according to the Z-axis.
Okay, you want me to go according to the z-axis? So according to the z-axis, it will go up like this, right?
Yep.
So x squared plus y squared, what is it actually?
It's actually,
R squared?
yeah, R squared.
What is R squared?
R squared is R squared minus Z squared.
Are these two are different?
Yeah.
So right now, using this, we can calculate that volume. So here we can have pi, which R? Which R square? Capital or small? Okay, small. And this is D, Z. Am I right?
Yes,
What would you want the range to be?
And don't forget there's a 2 in front.
Okay, you want a 2 here, right?
Yes,
That means
sir.
it'll be from 0 to R.
So it'll be R.
So for this, pi can take out.
Yeah.
Then R square will be,
R squared will equals to,
is that right?
yes,
Stand up. Okay, so for this, can you erase this part first while I talk about this? Erase this part first. Okay, so for this 2R, you see you can separate this, right?
yeah.
Like this, is it right?
Yeah.
So, is it right like this? Here you have the R square, and inside here will be the dz, right?
Yeah.
So here, because that is becomes a z cube, so in front here we need to have an over 3. And remember, this is actually just integration right now. So for this, we can sub in. Like this, is it right?
Yeah.
Okay, so there is a, right, okay, 4 over 3 pi r cubed. Yes, correct. So this is for the first way, right?
Yeah.
Do you know what is the second way?
Okay.
So can I use it?
Yeah.
Okay, you don't need to write that high. So which do you want first? So you put the x squared and z squared together. Okay, so that means you go according to the y, right?
Yeah.
Okay. Yes. So that part is the pi r squared is the area of each disk. And this dy. And remember, when these two times together, it's the volume of each disk.
Okay.
So for this, okay. Well, I think you missed out something. Your square. Remember, r squared. Continue.
Okay.
Okay. Then continue. So for this part, you have both two y's, right?
Yes.
So next for this, you can just integrate. Okay, so you straight away start that boundary in. Okay, so yes, there you get the right answer. Okay, so this is for the second method. So for this second method, you see, you go according to the y. Okay, so when you go according to the y, so next method we can go according to the x. So like this. Okay, let's take another look at all of these, okay? Okay, we'll erase this right now.
So the next one you use.
So next, I'll use the last method, or the disk method.
Okie dokie.
Means I'll go according to x.
Okay. Since you say that, that means that will be from like this. So that means the Z point will be over here. And we'll keep chopping down.
Chopping?
Okay.
Okay.
And for my y-axis, it will be here. Then it will keep chopping like this. And the x point will be here and it will keep chopping like this. So this will be Z, this will be Y, and this will be X. I mean, this will be X.
Yes.
This will be Y. That much better. Correct.
So we'll have it like this, am I right?
Yep.
So these are actually the 3 ways, alright?
Correcto.
Okay, so this totally is a second method, the disk method.
Yeah. Disk.
Okay. So remember, it's the whole thing, okay?
Yep.
And this is 3D shape. The whole thing is 2D. Because
Yep.
a sphere can't be 2D, right?
Yep. Plus because when we write, we always write 2D. You want to sing plus 3D?
Okay, so this is another way to prove the volume, right?
Yeah.
Okay, so I clear up all of these.
Yep. And what you want to say?
Okay, if you like our videos, don't forget to subscribe to our channel.
Okay.
So see you on the next lesson.
Yep. And we'll continue